In this video, I will go over the homework that follows the lecture focusing on telescoping series. And as always, I hope that you watched this lecture. And let's jump right into the homework. And the first problem is right in front of us. And the good thing is that we are told that this is a telescoping series, so we don't need to go through the our toolbox and try to figure out whether it is or it isn't. So once you know something is a telescoping series, actually no, sorry, this is actually, they don't tell us, it actually says to determine whether it's a telescoping series. So a telescoping series will only have a few patterns, one or two that I went over in the lecture, and one of them has logs, and we use the property of logs in which we can compress or expand logarithmic expressions. The other one is fractions, where you can use what's called partial decomposition and decompose a product into a sum or difference of two fractions. Those are the two main patterns, and since there is no rule that I guess we can try to write it out, right? So the first term is 9 cubed plus 9 to the 4. The second term is 9 to the 4 plus 9 to the 5th. So S1 is 9 cubed plus 9 to the 4, and S2 is just 9 cubed plus 9 to the 4 plus 9 to the 4 plus 9 to the 5. So, and as you can tell, there's nothing being telescoping here, so these two terms do not collapse, and therefore we would conclude this is not a telescoping series. However, change this plus to minus, and then it could be a telescoping series. All right, second problem is what I thought the first problem was. We are now given that this is a telescoping series, so we don't have to worry about proving it. And in this case, if you notice, A1 is 4 over square root of 10 minus 4 over square root of 11. A2 will be 4 over square root of 11 minus 4 over square root of 12, etc. So that means S1 will be A1, and S2 will be 4 over square root of 10 minus 4 over square root of 11 plus 4 over square root of 11 minus 4 over square root of 12. And here we see this telescoping behavior. So the middle part just collapses. So I would say this series is telescoping, which, again, we weren't asked to do that. I, for some reason, did it anyway. And now to determine whether this series converges or diverges, we have to consider Sn. And Sn will be A1 plus A2 plus A3 and so on plus An. And here we see that A1 will be 4 over square root of 10 minus 4 over square root of 11 plus A2 4 over square root of 11 minus 4 over square root of 12 and so on. And this behavior will continue, and the nth term will be 4 over square root of n plus 9 minus 4 over square root of n plus 10. And this is the telescoping behavior. So all the middle terms will collapse, and at the end we will only have 4 over square root of 10 minus 4 over square root of n plus 10. And what does that mean? That means to determine the convergence of the series, we now have to analyze the convergence of this sequence, which is much easier. And this particular sequence, you can see that this term just goes to 0, so the whole thing is just 4 over square root of 10. So this series converges. We have another similar example. We know that this series is telescoping, so let's write Sn. Sn will be a1 plus a2 and so on plus an. The first term is 5 over square root of 8 minus 5 over square root of 9. The second term is 5 over square root of 9 minus 5 over square root of 10. And we can apply this pattern all the way. So the nth term will be 5 over square root of n plus 7 minus 5 over square root of n plus 8. And because it's telescoping, all these terms will cancel out. So this is the only thing that's left. So to determine the limit of this series, we can just find the limit of the partial sum of the sequence of partial sums, which is easy to find. Again, this goes to 0, but it doesn't have to. So we could have had a problem in which that term doesn't go to 0, and if it doesn't, then the series may not converge. So just remember, telescoping doesn't always mean it's converging. Oops. Another problem. This is a telescoping series. So we're going to find the sequence of partial sums. It's going to be the first element, the second, up to n. The first element here is 3 over square root of 6 minus 3 over square root of 7. The second element is 3 over square root of 7 minus 3 over square root of 8. The nth term is 3 over square root of n plus 5 minus 3 over square root of n plus 6. Now, because it's telescoping, or this is what makes it telescoping, everything collapses. So this is the nth partial sum. So now we can find this, the limit of this series, by finding the limit of the sequence of partial sums. And this goes to 0, and the answer is 3 over square root of 6. And we are done. If you have any questions, please reach out.